My name is William Johnson, and this is my Physics 2211 presentation for Lab 1 that deals with constant velocity. In this lab, I will be introducing key quantum principles. I will be analyzing the glue-stick's motion via tracker. I will identify the computational model via GlowScript, and I will compare the predicted results to my computational results. Finally, I will answer the questions of what if and what does it mean. The purpose of this lab is to analyze the motion of an object as it moves at a constant velocity to determine its position over time. Also, I will design a computational model via GlowScript to replicate a real-world scenario. Then, I will compare the computational model via GlowScript to the video analysis via tracker and identify the key differences. When comparing the two models, the observed model had a greater average velocity than that of the predicted motion of the computational model. The key concepts in this lab were Newton's first law and Newton's second law. Newton's first law states an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an unbalanced force. Newton's second law states that a force applied to an object at rest will cause the object to accelerate in the direction of that force. This law can be demonstrated in these two equations, the position update formula and the velocity update formula. The position update formula states that the final position is equal to the initial position plus the average velocity times change in time. The velocity update formula is demonstrated by the final velocity equal to the initial velocity plus the net force divided by mass times the change in time. When the net force is zero, the object is either at rest or moving at a constant velocity and will remain this way until an unbalanced force acts upon the object. For this lab, I selected a glue stick as the system and the rest of the room as surroundings and assumed friction and air resistance were negligible. I used the y-axis in tracker as my x-axis due to the video being flipped when entered into the program. I used the up direction to be the positive direction on the x-axis. As you can see, the glue stick moves upward into the positive y direction, but I chose to use that, flip the axis, and make that the x-axis. Here is the code for my computational model. I only changed a couple things within this from the starter code given for the lab. I changed the mass of the glue stick. I changed the initial position to equal the initial position of the object, the glue stick. I changed the initial velocity, which was calculated by determining the initial position divided by the change in time between two frames, which is 0.0333. Then I changed the deltat to equal the time of each frame. For the while loop, I want it to end at the time of the final position, so I changed that time. Next, for the update of the velocity, I used the velocity update formula to update the velocity in each time frame. For the change in position, I used the position update formula. Here's the observed tracker versus computational, the observed via tracker versus computational via GlowScript graph. The blue represents the observed model, and the red represents the computational model. As you can see, the tracker model is slightly high, has a slightly steeper slope than that of the computational model. Therefore, this reveals that the tracker velocity was slightly higher than that of the GlowScript velocity. The observed results and predicted results appear more similar the smaller the value of time is. The tracker results showed that the glue stick moved at a higher velocity than that of the GlowScript results, as illustrated by the steeper line generated by the tracker model. The difference in positions and velocities collected by the two models, coupled with the inconsistent data points collected via the tracker model, reveals the velocity did not remain entirely constant throughout the given time. The velocity most likely did not remain constant due to forces acting upon the glue stick, such as friction or air resistance. What if? What does it mean? If I were to flip the axis, this means the right direction would become the negative direction, and the left direction would become the positive direction. In this case, the position values would become negative instead of positive. When an object moves at a constant velocity, it can be assumed that the net force is zero. However, it is impossible to determine just how many forces are acting upon the glue stick that is causing the net force to equalize to zero. There are so many different forces present on Earth that can lightly or heavily impact the motion of an object, so it is difficult to determine which ones are currently in play. To wrap up this lab, in Newton's first law and second law, friction, gravity, and air resistance are examples of unbalanced force that can cause an object to rest, to move, or an object in motion to stop, speed up, or slow down. In real life, it is impossible or extremely difficult to achieve a perfect constant velocity due to many forces that are constantly acting on objects such as gravity, friction, and air resistance.